We have already learned about Newton's law of gravitation and the formula. Now the next concept that we need to learn is the gravitational field. Okay, so the gravitational field is a region in space where a mass experiences a gravitational force. Okay, this is to help you visualize, like, why is there this action in a distance kind of force. Okay, we are more used to what we call contact forces. Contact forces are forces that can only be exerted when you have contact between two objects. For example, a push or a pull. You can push the wall, you can push a box, and obviously there's contact between the two objects, and that's how a force can be exerted. But gravity and electrostatic forces are examples of action in a distance force. Look at the two objects here, which one can be an Earth and the other is a moon, right? They are obviously not in contact, but why is there a force between them? So one way to visualize this is through the gravitational field, okay? And we can actually define the gravitational field strength at the point as the gravitational force acting per unit mass at the point. So mathematically, it's G equals to F over M. And because F is a vector, so gravitational field strength is also a vector. And it has the same direction as F. Take note of the units, it's newtons per kg. Okay. And we can even derive the formula for G. Okay, so looking at Newton's law of gravitation, F equals to gmm over r squared, you can divide by the m, because the m is the mass in question, right? So this big M here, it sets up a gravitational field. Okay. So this big M here, it will set up a gravitational field, right? And this M, this small m here, will then experience a gravitational field strength. And so to find the gravitational field strength at this point, we will have to take the force on M, which is this force, okay? So this force here divided by the mass of this small m, right? Okay, so this G here is the gravitational field strength due to mass m. That's how you figure out which m to divide by, okay? So, and take note that this final form has got m, capital M here, but it has got no small m. Okay, so this is gravitational field strength is set up by the big M, not the small m. Another exercise that you can try is to show that newtons per kg is actually equivalent to meter per second squared. So in this case, the units is meter per second squared, which is actually a very familiar unit. It's actually acceleration due to gravity. Okay, so just to confirm that this is indeed the case, okay, because this is the formula that you are very familiar with, W equals to mg, right? And this is actually gravitational force. Okay, so G is acceleration due to gravity. This equals to this gravitational force over m, which is actually how we define gravitational field strength. Okay, this graph shows you how the gravitational field is actually an inverse square law field, right? So if we were to plot G against R, it will be a curve. Okay, that's 1 over r squared curve. And note that on the surface of the planet, the gravitational field strength is the maximum, that's G. Now, as you move away from the surface, as you go to a higher and higher altitude, the gravitational field strength decreases. Okay,